Hey, and welcome back. So now I have set up my basic foundation, my scaffolding, if you will. So now I have my folder structure in place, and I have also opened all these tabs that I showed you last time, so I can go to libraries, constants, tables, variables, whatever. So now I'm ready to actually do some coding here. Now we've done a little bit of coding with the main.asm, the game code ASM, and the memory map. So we have those very basic things in place. And also here in my main file, I have also filled in all these entries from the memory map. So the different memory addresses. And like this one, for example, sprites. Like I told you, I like to do these things from the beginning. So this sprites file just contains a lot of blank sprites, sprite graphics, but I like to fill everything in from the start, especially when I do the math first, so I know how much space the different things are going to take, and I just fill them in like that. So now that I have done all that, and I've actually run this code as well. So now we can take a look at my main build log file. Now I've already run this code, so Kick Assembler has made this for me now. So you remember this main build log file, right? The ones where we see our memory map, and this is the thing that we can use for Noise Kick Assembler memory viewer. So how about if we do that right now? So here we can see in our Noise Kick Assembler memory viewer, I've pasted in the code from the file, right? Main build log file. And by doing that, I can see how much space the different things are taking up in memory. So if we see this one, for example, from address 2000, well, that's my sprites. So we can see here. So we can see that I've already started to fill up some space here in memory before I even had started drawing sprite graphics. But just filling that file in there is still going to take up space. So I'm talking about this file, the file that I exported from SpritePad. So, but this is kind of nice. Now we see this is at the very beginning, right? But we're starting to see where we are filling up space. So again, it's just a nice thing when you're setting everything up like this, is that you know what's going on. You won't get any big surprises, hopefully. But now let's get back and see what do I do next. Now when all these basic things are in place, what do I usually do next? So when all my basic things are in place and have made these three files, main ASM, game code ASM, and the memory map and all that stuff, and I've also here in my folder structure, I've also made these constant files, for example, screen constants, the ones that addresses that I'm knowing going to use, right? The one for screen RAM, screen memory setup, and all those things. And I've also made this one for system constants. So I briefly showed you this one before, the one called process support, which is address 0001. So I might be, it looks strange right now because there's only one constant in here, but here are my system constants, and I might want to fill in more later on. But my point here is that I have made some constants here. I have even made one for for raster interrupts. So here, current raster line, for example, the one at D1012. Yeah. There are a few of these for the raster interrupts. Now, let me just repeat what I said last time. And don't get me wrong, raster interrupts are important, and they are really nice to use as a feature in our game, because they're going to help us with a lot of stuff. Like, for example, moving sprites smoothly around the screen without any sprite tearing, without any weird effects. And as I said, it's really nice for playing music in the raster interrupts. But my point when I was talking about this last time is that, as I'm sure you've seen, there is so much to learn, so much to remember, and so many things to set up and everything. So my point last time was that it's okay now in the beginning if you just, for example, get some example code to set up raster interrupts. And now, hopefully, you understand, like I said, what it is, how it works, and why we use it. So you understand this at the conceptual level, but it's okay if you don't program it completely from scratch, that you understand every little thing in here now at the beginning. Because it's more important that you start programming the basics. And just by having some let's call it a default raster interrupt setup that works, that's okay in the beginning. Because let's take a look at my raster interrupt library. So yeah, let's not go into detail right now, but we know about this routine, this raster interrupt routine that triggers at a specific raster line. So we know that how that works. So if you have this setup and it works, then that's okay in the beginning, because you know that here in the interrupt routine you can specify what you want to happen. So I just wanted to mention that so that you don't misunderstand me, because when you get comfortable with programming and you get better and better and better, and maybe you understand this raster interrupt thing a little better as well, and then you can make more advanced things. But now in the beginning, it's perfectly fine to just use this default, if we can call it that, some example from online or whatever. Okay, I just wanted to mention that very quickly now, because we were looking at this constants file for my interrupts. Alright, so now here I am in my, my point was that I've set up a lot of constants. I have this whole setup, a lot of constants here. I have my temp variables, we already saw those. And I need to mention that I also made my config file, which just looks like this right now. So I have a config file. It says screen width 40 columns, screen height 25 columns, screen size, screen width times screen height. Now this one I'll probably not need too much, but it can be nice to have. And since I'm not going to, since this doesn't take up any space, it's perfectly fine just to keep it in here. But then some more important things comes down here. Default screen border color, I've set that to black. Default screen background color, purple, and so on. So I just made some labels here for these things, and my whole config file is just labels, right? So what I do now, as you can see here in my gamecode.asm file, one of the first things that I do is run a routine called setup. Where is that setup routine? Well, because of my system with scoping, we can see that it's in the system library. That's as I said, that's the nice thing about using scoping this way. We know where this setup routine is. But let's also quickly notice that the very first thing, so the absolutely first thing that happens is my Commodore basic line that just kickstarts my whole thing here. my 10 sys, you know, the basic line of basic here. That's the very first thing. But then in my assembly code, this is the very first thing. So the absolutely first thing I do in my code is initializing the stack pointer. Load X with hexadecimal FF, transfer X to the stack pointer. I said transfer X to the stack last time. It's transfer X to the stack pointer. Anyway, initialize stack pointer. That's the very first thing. But then I run my setup subroutine. So let's take a look at my system library. So I made a file called systemlibrary.asm. And if you remember from scoping, I just wrote a label here, and I use capital letters for my scoping scope names, like this. And I start with a curly bracket here, and I end with a curly bracket down there. So here in the middle, I have specified a subroutine called setup. Now, as you can see, it's right under main here. So this is going to set up all my basic things. So what are those basic things? Well, I start by disabling basic. So the way that I do that is by using this SEI. Now, if you remember, that was disable interrupts. Why am I doing that right now? Well, I'm changing things here in memory address 0001, the processor port. I'm switching around the ROMs. I'm saying to the CPU or to the computer, I don't want basic right now. You can disable basic. And in memory, if you remember from the memory that we looked at, we are disabling basic from that area. Okay, let's take a look at that right now to make it more visual. So what I'm talking about is this area right here. This area from 8000 all the way up to C100. I'm gonna disable this, and I usually do that for all of my projects because I'm not gonna be using any basic code in my assembly project. Now you could do that, but we're not gonna look at that. But I don't need this basic RAM to be here. So I just disable this whole thing, which is going to turn this into RAM. So this area will now be RAM. However, I've mentioned this before. The way that we have set up Kick Assembler right now means that we can only start filling up memory up until here. It stops here because of this basic area. So we don't have to go into detail about that, but just remember that if you import like this here in your assembly code or in your main.asm file, then if you do it this way, you can only import up until the basic area. So up until 8000. You can't do it further than that because basic is there when we're starting this. So if you want to use that area, then you need to, for example, like I said, after your program has started, you need to do some kind of load routine. For example, load from diskette, and then you can load stuff into the area that where basic was. So because if you disable basic, now that area is free. So now we can use that for whatever we want, but in order to use that area, you need to do something special. Okay, enough about that. For now, just remember that we can't import beyond address 8000. Okay, the point is we were here in my system library. So I disable interrupts. I use this combinations of ones and zeros in here. Why exactly this combination? Well, once again, this Commodore 64 memory map web page comes in handy, because here at memory address 0001, the one that I'm working with right here, it explains again what these bits do. So bits 0 to 2. So bits 0 to 2, that's this one, bits 0, 1, 2. Those bits has to do with the configuration of memory areas. So like we just looked at, for example, the basic RAM. Configuration for memory areas 8000 A1000 to BFFFF, D1000 to DFFFF, and E1000 to FFFF. So all the RAM areas that we have seen a few times. So we can switch them on or off. If they're switched off, then those areas become RAM, free RAM. But like you just saw with the example of the basic, we have to do some special things to use those areas, like loading from disk, for example. And I also have to mention that this area, D1000, memory area D1000 to DFFFF, that entire area, at least now in the beginning, I would be very, very careful to disable that area, because there's so much going on in here. So if you disable that area, you're going to have some problems. For example, you have seen a lot of things we use in there. D020, the border color, D1000, the address for the sprite X and Y position, and stuff like that, and that's just the beginning. There's a ton of stuff, and input output especially, that's probably the most important thing. So for now, let's just stay away from disabling this area at D1000, because that's pretty complicated. So IO area at D1000, let's just leave it like that. But anyway, the whole point here was that by looking at this memory page, this web page, I can set up my processor port to disable basic. And we have already spent way too much time talking about this memory address, but it's important to know that my point with this was that there's a default value for this memory address. So what I did, I just copied that, but from reading here, I can see that here it says RAM visible from A1000 if I switch the last bit to 0, which is what I did right here. So after all that, my whole point was that just by changing this, taking the default value here, changing the last bit to 0, but just by doing that, I disable basic. So sorry, that was a lot of rambling, but that was the whole point. But hopefully we learned something during that rambling. Anyway, we are in the system library right now. So now, after all that, I have disabled basic, and I need to remember to reactivate system interrupts, CLI. Then we have seen this before. I set up my screen memory setup. So by using these bits here, I set up screen RAM and character set, where I want those to be. That's also something that happens in my system setup routine. Disable basic, set up my screen like that, and I enable screen multicolor in screen control 2, D1016. If you remember, this was D1018. So now, here comes the neat part of my config file. Here I say load A with default screen border color, which is this label from my config file. So in reality, what I'm saying here is load A with black. And if we go one step further, we know that black is color code 0. So when all comes to all, what I'm actually doing here is this, right? Load A with 0. But writing this makes so much more sense to us as human beings. And now we don't forget what this is. Default screen border color. That was this thing from my config file. And whoops, I load that. Very important, with a hashtag in front of it. This is not a memory address, so I need a hashtag in front of it. So load that and store that in the actual memory address, screen border color, which of course is a constant here. So memory address D020. So I just do it like that. Read from the config file, store into the actual memory address. Read from the config file, store into the actual memory address. So I just do it that way. Set up all the color information. Then finally down here, I clear the screen. We have already seen that. And the last thing that I do is from my interrupt library. I run this routine called setup raster interrupts. So in my setup routine, I do all of these things and also activate raster interrupts. So all of that is going on right here. So the reason that I do it that way is just by running this subroutine, I set up everything. So I don't have to clutter up my game code file here with any of that stuff. And if at some point I need to change something, maybe I need to add something to my system setup, then I just go into my system library and change my setup routine here for whatever reason. But I feel that this works out really well. So initialize a stack pointer, run my setup routine. So even though my game setup code here on game loop is completely blank now, and I just have these few lines of code, I still have something going on. So let's try to run my code now and see what happens. So I got a new border color, I got a new background color, my screen was cleared, and if you see down here, I made a little example in my raster interrupt routine, so we can see that yes, that's also working. So just by doing this, of course we know that there's some more going on in here, but in my game code file I just have this, and now I have my basic setup working. So that's really nice. And by the way, you can also see here that I said I like to start my or trigger my raster interrupt just below the screen background area, and that's what I've done here. Line 250. All right. Anyway, so this is the very start of my project. I have everything in place with my folders. I've started to make constants and all those this main file and all that stuff, and just by using my system library here, I have a very basic setup. Now notice one more thing here. We are in my system library and my system subroutine. I do all these things, but down here I run another subroutine. So you can run a subroutine within a subroutine. So I'm in a subroutine right now, and well, we actually do that here as well, but here we run another subroutine as well. So as long as we use RTS in our subroutines, they return to where they were run from. So it's not a problem. You can do it that way. So what we need to do right now is to look at my interrupt library. So here we are in the interrupt library, my library for raster interrupts. And here is my setup raster interrupt routine, the one that I run from my setup here in system. I go down here, interrupt, setup raster interrupt, that's this one. So we have actually seen this one in the episode about raster interrupts. So we don't really need to go into any more detail there. And like I told you, if you just use the files that I give you in the beginning, it's fine. You don't have to worry about it. But you need to understand why we use it and how this works at the basic level. So as you can see here, I trigger my raster interrupt at line 250. And what my raster interrupt routine does right now is I acknowledge that we have a raster interrupt. But what I actually do is change the border color to light green. And like just we saw in my example before, I have a little delay loop here. And then after that delay loop, I change the border color to black, which is the reason that we see this fat green line at the bottom of the screen. So I just did that to show you that my raster interrupt routine, it's actually working. Now I have another example, because this is something we haven't really talked about, because we're talking about raster interrupts right now. So here now we actually looked at the whole thing, my system setup routine and my raster interrupt library. Now I can also mention that I have two other subroutines here, one called enable raster interrupt and one called disable raster interrupt. So what if I for whatever reason want to enable or disable the interrupts, I can do it by running these subroutines. But my point was that we're talking about raster interrupts now. So I have another example, like I told you, and what I'm getting at is that I've said that raster interrupts interrupt the CPU. So the CPU, let's say we are here now, and we are in our game loop, which is going over and over and over again. So we know that at line 250 now, that's triggered a raster interrupt, which means that the CPU stops whatever it's doing right here. It goes to my interrupt routine, which is this one, and it does whatever it has specified in here. And when that's done, we go back here and continue as normal until the raster line reaches 250 again, and so on. So it's back and forth like that. My main point now was that for us as human beings, this is almost going to feel like these two things are happening at the same time. So we're going to get some sort of experience that it's almost like a dual processor, that you have two things going on at once. And to show you that, I made an example. So I'm going to go into my interrupt library now. I'm going to remove this color thing, like that. And here I have a little line of code that says inc D1001. Now, if you remember that memory address, that's the Y position of the first sprite. So that's what's going to happen in my raster interrupt routine. I'm going to increase the Y position of my the first sprite. That's the only thing that's going to happen. Increase the Y position of the first sprite. So I also have something here that I'm going to paste into my main code. So let me take this one first. So here in my main code under game setup, I'm just going to say load A with 100. Store that into D000 and D0001. Now let me also just briefly mention something else. We can see that I'm loading A with something here with 100, and I want to store that in both the X position and Y position. But since I'm going to store the same number, I don't need to write load A with 100 again, because I don't change anything in my accumulator by storing it like that. So I just load A with 100 here, and then I store it here. So storing A does not change the accumulator value. Alright, that's a little sidetracking. But anyway, I load A with 100, I store that into X and Y position. So X and Y is going to have their start position now. And I say load A with 1 here, which is going and store that into D015. So that's going to activate sprite 0, the first sprite. That's going to activate it here. Alright, so what else? Well, I have something here. So if I go to my game loop now, and inside my game loop, I make a little delay loop here. So this delay loop is going to run, I load X with 0, and I increment X here, branch is not equal, so this is going to run 255 times, like that. What's happening in here? Well, nothing really. We have this NOP, no operation. So this is literally just a delay loop. It's just going to delay something. And the reason is, as you know, because sprite moves so fast. So I'm going to slow that down now. And as you can see right here, I'm increasing the X position of the sprite. Alright, what am I getting at here? Well, this is just an example to show you how I said that we are going to experience that this game code and the raster interrupt is working at the same time. So this is an example to show you that. Here in my game code, in my game loop, so my main code, in this file, I just increase the X position. Just increase the X position of the sprite. And we already saw that I placed it here and activated it. And in my main game loop, I just move it to the right. Alright, fine. So what's happening in my interrupt routine? Okay, here I'm increasing the Y position. So in my main code, I'm increasing the X position. In my raster interrupt routine, I'm increasing the Y position. Like I said, the experience is going to be that these are happening at the same time. Let's see if that is the case. So there we go. So now we can see that the sprite is moving both down and to the right, and we can see that it feels like it's happening at the exact same time, right? Because everything is happening so fast that we can't tell that, oh yeah, now we're switching to the raster interrupt and now we're switching back, because it's happening so fast that the experience we get is that it's happening at the same time. But notice something else here. Can you see that the sprite is moving faster to the right? It's moving faster to the right than it's moving down. It's moving fast to the right, but a little slower down. So it's not a 45-degree angle, it's more of a slant like that. That's because our main code, my game loop here, is running so super fast. Even though I've included a delay loop here, which does nothing, absolutely nothing. 1, 2, 3, 4, 5 of those. Not just that, but all these 5 no operation, all of that runs 255 times. And despite of that delay loop, we're still moving faster to the right than we're moving down. So the conclusion is that our main game code is super fast, and our raster interrupt routine is not so fast. So it's not running quite as often. So that's why we're moving slower down than we're moving right. Because the raster interrupt routine on my PAL system here only runs 50 times a second. So my Y position is updated 50 times a second. But my X position here, I don't even know how many times every second. It's super fast. So I just wanted to show you that example so that you could see it with your own eyes. Okay, well, I think that's enough for now. So now we have seen the basic structure, folder structure, setting all the constants in place, memory map and all that stuff, and that I like to start by setting up my system library like this, and also making sure that my interrupt library is in place. And in my system library I also activate raster interrupts. So that gives me a base. So now everything is in place, everything's working. I don't have any sprites or fancy background graphics or anything, but this core system is in place. And now I can start programming some more logic. And that's what we're going to do next time. So I'll see you then. Bye bye.